Welcome to Chapter 3, Section 3, Properties of Logs. We got 4 bullet points here. We'll do the first 2 in this video, call it Day 1, and then there'll be a sequel video, Day 2. In this one, we're going to check out what they call the change of base formula to rewrite and evaluate log expressions, and then use the properties of logs to evaluate or rewrite expressions. And then in the second video, we'll do these 2 down here. Let's dive right in. So most calculators have only 2 types of log key, one for common logs base 10 and one for the natural log base E. Although common logs and natural logs are most frequently used, you may occasionally need to evaluate logs of other bases. To do this, you can use these change of base formulas, and these are so easy. Here we got log base A of some number x, and we can change that base number to b if we break it up into log base b of the big number, x in the numerator, and log base b of the old base number a in the denominator. But that one's not very useful. We're not going to get a lot of mileage out of it. It's these 2, because these are buttons on our calculators. If you get log base a, and that a can be any number of some number x, you take the common log of the big number x, and then you take the common log of the old base a, and you divide those, and that is the log base a of x. And you can do the exact same thing here with the natural logs, because if you look here, it's log base a of x. We'll turn that into the natural log of whatever that big number is, and then underneath that we'll divide by the natural log of the old base a. And you just punch those buttons on your calculator, and you get your decimal equivalent. Now, there was a change in the new edition of the book. We're going to do this one here, A, in the example. This one for B is actually the checkpoint, the practice problem you're going to do on your own. But let's check this one out. Log base 4 of 25. There is no log base 4 calculator or button on our calculator. So we'll do the common log of 25 over the common log of 4. So get those calculators ready. And the log of 25 is approximately 1.39794. And we're going to divide that by the common log of 4, and that decimal is 0.60206. And if we divide that numerator by that denominator, again, we get approximately, because these are all rounded, 2.3219. That is our log base 4 of 25. Okay, so there we did that one with the log, the common log. Here they ask us to do the same thing. Again, this will be a practice problem. Do the same thing with the natural log. So it's the same log base 4 of 25, but now we're going to make it the natural log. Let me back that up. The natural log of 25 divided by the natural log of 4. And if we turn those into decimals, natural log 25 is 3.21888. And the natural log of 4 is 1.38629. And if we divide those 2 decimals, we get our final answer, 2.3219. The final answer is the same because the log base 4 of 25 only has one answer, and we found it by doing different decimals. If I click back to example 1, notice our numerator was about 1.4, our denominator was 0.6. Here our numerator was 3.2, our denominator was 1.3. Different numerators and denominators, but they divided out to be the exact same answer. Isn't math beautiful? So here, pause the video and give these a try. Do the exact same thing that we saw in the example. Okay, I'm not going to go through and write down all the decimals that you should have found. You should have them in your notes because you're supposed to be trying these on your own. But the first one there, you should get approximately 3.5850. And then when you do the same thing, well, let's do the setup up here. That would be the log of 12 over the log of 2. Find those decimals. I want to see them in your notes. Down here, you're going to do the same thing, but it's going to be the nat log of 12 over the nat log of 2. You'll get 2 different decimals, and when you divide those out, 3.5850. Okay, what's next? Properties of logarithms. Here we've got the product property. So we've got the log of some 2 things multiplied here, u times v. We can turn that into the log base a of the first thing, u, plus log base a of the second thing v. This is sort of the reflection of that property. When you are multiplying like bases, you're adding exponents. Here we're multiplying these two things and we turn it into two logs added together. Same thing with natural logs. Nat log of u times v, make it the natural log of the first thing u plus the natural log of the second thing v. So that's a product property or multiplying. Here's the quotient property. Back when you're thinking about exponents, if you are dividing like bases, you subtract exponents. So there we'd have base x. 6 minus 4 is, or 6 minus 2 is 4. And then remember, logs here are just a different way to look at exponents. So now we've got the log of two things divided. U is the numerator, v is the denominator. I always imagine that division bar became this minus sign in between. And then we've got the log of the numerator minus the log of the denominator. And of course, it's natural log equivalent. The ln of u divided by v becomes the ln of the numerator minus the ln of the denominator. Okay, and here, this last one, the power property, it's probably my favorite property of logarithms. If I've got log base 2 of x to the 4th power, I can bring this exponent down front and make it a coefficient. So that would just be 4 log base 2 of x to the 1st power. And that also works with natural logs here. They got natural log. I'm going to just make it like x to the 3rd power. That 3 can come down front, and it would be 3 times the natural log of x. And those are useful to condense and expand out logarithms. We'll do more of that, I believe, in the day 2 video. In example 3 here, they want us to rewrite some given logs in terms of only natural log of 2 and natural log of 3. These are like the building blocks, and we want to break down what they gave us into those components. So when I look at the first one, letter A, I've got a natural log of 6, and we got to sort of break the 6 down. So natural log of, another way to write 6 is 2 times 3. So that'll be the ln of quantity 2 times 3. And now we've got two things multiplied there. So we can use the product property and make the natural log of the first thing plus the natural log of the second thing. And we've rewritten it in terms of ln2 and ln3. So part A is done. Part B, we've got the natural log of, I see upstairs is a 2, and that's good because that's one of our building blocks. Downstairs we've got a 27. And we could write 27 as 9 times 3, or 3 times 3 times 3, which is 3 cubed. So we can kind of see our building blocks are there. We've got 2's and 3's. Now let's use some of our properties. Here I see the ln of a quotient. So we can break that down into the natural log of the numerator minus the natural log of the denominator, 3 cubed. Now we're almost done. Remember, our building blocks are what we want to break this down into, our natural logs of 2 and natural logs of 3. Well, that 3 cubed isn't quite right. What we're going to have to do is that last property where we can take that exponent down front and tuck it in front of the log for our final answer. So now we've got the natural log of 2 minus 3 natural logs of 3. So again, we've fulfilled the directions to write the log in terms of ln2's and ln3's. Mission accomplished. All right, using the properties of logs, find the exact value of each expression. You don't need a calculator. And I believe this part B here, this is going to be one of the checkpoints, the practice problems you'll do on probably like the next slide. So let's look at this one. Exact value without a calculator. So I see a log base 5. And then we got a cube root of 5 to the 1st. I can write that as 5 to the 1/3 power. Now, if you look in the textbook, the book likes to bring this exponent down front and write it as 1/3 log base 5 of 5 to the 1st. And then they mention the property where this log base 5 of 5, that just turns into a 1. So that becomes 1/3 times 1, or 1/3. But then there was also another property that said if you have log base 5 of the same number, that's just equal to whatever this exponent is. You know, here the exponent was a 1. We could just cut right to the chase and say the log base 5 of 5 cancels, and the 1/3 is our final answer. All right, checkpoint time. Pause the video and try these out. This one is just like the one with where we had ln's of 2's and 3's. You just want to break this up into log components. And then this one here, just apply the properties of logs. You should be able to solve this without a calculator. All right, first one, we've got a log log, a common log of 75. And 75 we could write as 3 times 25. And that 25 we could rewrite as 5 squared. So now we've got a log of a product. So we can write that as the log of the first thing plus the log of the second thing, 5 squared. And then that final property allows us to bring these exponents, like this 2, there, got it, down front and make it a coefficient. That's an ugly 2. Let me get rid of that. Scribble it out, put a nice 2. There we go. So we've fulfilled the directions. It's written in log 3 and log 5 form. All right, now this one, I would take care of the 9 and the 125 first, I think. 9 is 3 squared. 125 is 5 cubed. All right, so we got a log of a quotient. We're going to make that the log. Let me move this over here. The log of the numerator, 3 squared, minus the log of the denominator, 5 cubed. And then I'm going to bring the exponents down. The squared comes down front, so now that's 2 logs of 3. And this 3 comes down front, 3 logs of 5. So final answer, 2 logs of 3 minus 3 logs of 5. Okay, here, the ln of e to the 6 minus the ln of e squared. Remember, base e and natural logs, they are inverses of each other. So this ln and this e will cancel, and that's just a 6. Minus the ln and the e cancel, and you get a 2. 6 minus 2 is 4. And I guess another way you could look at this, we could use the property to bring the exponents down. We could bring that 6 down front here. And then the ln of e just turns into a 1. So you could think of that as 1 times 6 minus. We could bring the squared down front as a 2. And then that'd be 2 times the ln of e, which is 1. 6 minus 2 is still 4. All right, that's it. We'll do some odd problems to practice in class, and you'll have some time for WebAssign. I hope this video helped.